This
We have
conference will now be recorded.
mutable collections, immutable collections. We had discussed even packages what we have there, and the default package like Scala.collections. Okay, that is the one which has all this the base traits are super classes, and from that there are so many classes which are doing the implementation, and we had a discussion on that yesterday. So that's the point. Okay. So now let's get into the little more detailed. Let's dive a little deeper into that. So collections hierarchy. We'll take one hierarchy, not so that we can first start discussing class by class. Okay. So probably hierarchy in we have to say in Scala. That will be more better for us. Okay. First thing, this is just an FAQ. 1 minute. We don't need FAQ. We need okay. Now, if you look at this, there are so many libraries. Of course, we have seen it. So we have two types of collections. One is immutable. That is one thing. The second one is mutable here. If you see, and all this we have discussed yesterday. This blue color, these entities. These are traits, and black color entities are implementation classes. We had discussed it yesterday. So the point is. They were saying like the most important collections what they were showing are the most important collections. Now the point is we have to start discussing from traversable and iterable. What are these first? We should get a quick idea. So when we talk about traversable or iterable, okay, traversable or iterable, second one is iterable. This is even in Java or even C Sharp. The collection concept is almost similar. This traversable, this is something like collection in Java. The root interface for all collections is collection, and the immediate child interface is iterable. Iterable is as is, we don't have any change in that. But traversable, they modified it to collection to traversable. These are the very core traits here for the whole hierarchy. And, what are these two here? These are the core interfaces where it has all the methods, common methods, which are applicable for the entire collection hierarchy. Okay, so that is one thing. So when you talk about these two, so what is that? These are the core types, which has all the common methods, which are implemented throughout the collection hierarchy, which are implemented throughout the collection hierarchy. Throughout the collection hierarchy. That is one. Okay. Now let us just check the API first. Okay, let's have a quick look into that API. What methods are there in that traversable trait? Let's just have a quick look into that. Okay, this is actually the library. This is where you can check for the whole information here. Okay, you have a lot of there are so many classes in the collection API, not just collection in the Scala API. Suppose if you want to know anything about that Scala API, a detailed analysis, what methods are there, what is the return type, what are the parameters, which class it is it a trait, is it a class, or is it something? If you want to have a very detailed analysis, if you want to explore more on everything, then you can do one thing. You can get to this Scala standard library, and you can search for that class here. You can see there. are tried here. When you look at it, it gives you a detailed analysis. Probably no doubt about this. These are the traits, no doubt. And then, and it has, what is that? So many methods here. You can see there. If you see, if I just keep scrolling, you can see there. Okay. These are all methods of which one? These are all methods of this traversable. Are you seeing, sir? These are all methods of traversal. Even there are some methods which are deprecated. Deprecated means outdated. So let's just have a quick look into this. Okay. And one thing here is very important. What is it? If you really understand what every method is doing here, okay, if you try to explore it, if you try to get into the shoe of each and every method here, okay, then definitely throughout your hierarchy, whatever you say it might be, what is it, map, or you say it is a set, or you say it is sequence, whatever it is. These methods are inherited to all those child traits. They are childs to this traversable, and even in those traits, the same methods are inherited. Then the point is, even the implementation classes of those traits, sequence traits or set traits or map traits, the implementation classes, probably most of those, they will implement the same methods according to the requirements. Got it right? So if you can understand these methods, every method in detail, point by point, so definitely what is this? This is going to give you a clear edge on these collections. And sir, if you look at carefully, I'm just showing you very few important methods in this traversable. I will just keep talking. Okay. So first thing, okay, let me come in a right order. Okay, this is traversable. You can see it is in the package. If you look at it, this is a parent package. Again, in that again collection dot, you can see here again collection dot immutable means this is sub package. Collection dot mutable, that is also sub package. Okay. So in this collection, again, there are mutable, immutable. There might be so many other packages as well. It's like folder inside a folder, sir. If you just want to get a quick idea, in one folder, you can create 10 more folders. But here, when you talk about packages, what is it? It's more or like it's just a folder. Okay, package is nothing but a folder. Inside this, you have all these traits and classes. That's what simple idea is that. Okay, and this traversable you can see here clearly. The signature you can find, the package you can easily find in the library. You can check here, and you can see the companion for this again at the right side, because all the fundamentals thoroughly, right? At the right side you can see what is the companion for traversable object traversable. Can you see that? Means this trait as a companion object again. Got it right, sir? So, and this guy, this fellow traversable is extending so many other, you can see there, they were so many other, this is a class, probably class, or it might be a trait otherwise. We are not sure. We can click on it and come to know that. So this is how so many, again, it is extending so many other traits or classes here. If you see, sorry, probably it might be extending a trait itself, sir. Probably traits don't extend classes, if I'm not wrong. They extend traits only. So if you click on it, that gives you a quick idea. You can see there it is a trait. Got it? And even this will be a trait. Can you see there? And even these two traversable ones, generic traversable template. These are all traits, no doubt. Without any second thought, we can conclude these are traits, because traits extends traits. Probably traits don't extend classes. Just for quick quick testing, because we didn't discuss this point in traits discussion. Something like class A, put leave it like this, don't put anything in that, just say trait some x. Okay, we can class extending traits, but we didn't see trait extending classes. Okay, I just want to quickly cross check whether this is possible here or not, just for our kind of cross checking. Okay, and immediately you can see error here. What is this? Okay, this is already the 1 minute. Let me make it as A111 like this, just for testing. So let us see now. Let me put a method. Still, I'm not seeing an error. Okay, I'm not seeing if I extend. Okay, that's fine. No issues. Let me put one method inside this. One more thing. I need to add few more. One, three, four ones here. Wait a minute. Now let us see if this will return error or not. I'll put one method, sir. D of M1 here. Okay, just println of test. But anyhow, right? Can we directly create an object for try? Not possible. Okay, now this has extended this, no issues. Now, what I can do now, I'll do one thing. Take one more class, y extends X. Just for this point is very important to understand the API, sir. Okay, so finally, what I would like to do here is I would like to create an object for this y, where y equal to new y, and then y dot one. Let me just see this scenario, because even this is very important for you also, sir. Okay, it's working. Means this is something really wonderful, because in Java, a class can implement interface, but interface cannot inherit class. That's not possible in Java. But in Scala, a trait can extend a class as well as a class can extend a trait. It is mutual here, it's vice versa. So this is also possible. Now it's practically true. Remember then, means what another important thing here is when you look at the API here, this a particular trait or a class can extend a class or traits. So we don't have an issue here. That's clearly tested now. The other, whatever the question that is there, that is clearly verified now. This is proved here. X is extending a class. That's possible in Scala. That's fine. Now this has all the common methods which are used throughout your uh, collection hierarchy, and it has so many very important methods. Okay, what is that? I will just figure out few important methods here. You see, collect. These are all like actions. Okay, like companion. Okay, copy to array, that's fine. Count, drop is fine. Drop while exist, filter. You can see filter is one important method we keep using in Scala as well. Sorry, not Scala. I'm sorry. Right now we are in Scala. In Spark as well. And flat map, we use this in Spark. Flatten, we use this in Spark. Fold. Most of these methods, not exactly, because Spark API is built, even though it's Scala. There might be some changes, but still, most of this what you are seeing here, exactly a similar name methods we can see in Spark, or with small changes we can use similar methods in Spark as well. So this flat map, this filter, these are all called what do you call them as generally we have two things in Spark, what we call them as actions and transformations. Okay, so when you talk about this, these are all, we'll talk about more on that action and transformation. So when you look at all this flat map, this flatten, this filter, okay, and all these are different types of methods we apply in Spark. Okay, group by, you can see, aggregate by, and even map is also one more important thing. Okay, we frequently use this methods in Spark. This map, this filter, this flat map, this flatten. Okay, and then this what is that, a group by, aggregate by. There are so many things which are even used in Spark actually. Okay, even those methods, all that partition is, this is also used in Spark. Okay, this is one important. I faced a question on interview on this before I cracked this thing while I was attending interviews. I still remember people asking questions on partition. Okay, reduce, one more function, very important function. These are all, I'm just pointing out what are important here. Reduce right, reduce left, you can check it and update. We can just test it and understand. Sequence, another method, you can see there, that itself is a method. Okay, sequence itself, there is a method here. And size, span, we need to, we cannot finish all these methods in one day. What we have to do is we have to take some methods every day. At least if there are some 20-30 methods here, at least if we can try start doing with a few methods every day, we'll finish off this whole methods first of all. Okay, and shadowed, you can see this filter, a flat map and with filter. These are very much used methods actually. Even reduce. Okay, all these are very much useful methods. Okay, so what is the Scala is doing is this traversable first thing. It is giving all this. It's having all this the very important methods which are used which are used throughout the collection hierarchy, and they are there in this right traversable, and it is present in the package scala.collection. Remember this, okay? So that's about this. Now suppose if we talk about iterable, maybe we can check it here. We don't need to get into there. Go there. We can do one thing. You can check here itself. Iterable again. You can check iterable. What is there in that? Probably, I don't think we have more methods here. Most of these methods are inherited from the parent itself. What is that parent? Parent from traversable. This is because you see this plus plus, all this were getting inherited from the parent. Few of the methods will be overloaded because you can see same methods repeated. They are overloaded. You can see this aggregate. Even this is also in Spark, instead of aggregate, we have something like aggregate by key, group by key. Okay, like that we have in Spark. Here we don't have. We have directly aggregate. We will check one by one. Okay. Now, this is the idea about even iterable. Okay. So this has all this common method. Few might be it will be adding few more to the existing to the existing methods which are inherited. Apart from inherited, might be this will be adding few more here. That's it. Even you have seen some split function. Even this is also important. Okay, take, we can these are all actions actually. We call these as actions. Actions means uh, when you call it automatically, it will perform. It will implement all the performs all the transformations till that point. That's what action is. Okay, we'll talk more clearly. Nothing to, no, we don't need to get confused at this point. So this is the idea about this, guys. Okay, so what I'm going to do right now is we have just observed the API and the methods, and we have seen so many methods. Now what we do is, first of all, you can test these methods with some class. You can take some class and you can keep testing them. What we do is we'll do one thing. These are simple, sir. There is nothing. Don't need to worry much about it. Give me a minute. There is one document from me with me, which where I have implemented all these methods. Not like this. Not this. The whole bunch of methods I have implemented. So you have observed, right? The thing, right? You have observed now the hierarchy and the traversable, the iterable, what methods we have, which are the most the finest methods, which are very used in Spark. And we see a lot of similarities with Scala code in directly in Scala, exclusive Scala and Spark Scala. Means even Spark is completely written in Scala, but still, point is what there will be few syntactical changes from Scala to the Scala which we implement in Spark, because as we are working on that Spark framework, the methods have little grammatical difference, means the syntactical difference. Okay, 1 minute, give me a minute. I have kept a should have one more doc where I have implemented all these methods. Not this one. This is the same one. Sheet 2x. Okay, I will find it and bring it tomorrow because now we have discussion to do. We have a lot of discussion to do. Scalar doc otherwise. Give me a minute. Let me check here if it is here. Not this. Okay, no issues. I will check and find it and bring it because we have implemented so much on that. Fine. Now, what I'm going to do is let us switch to the hierarchies first. If you look at this, take any one hierarchy, either mutable or immutable, anything is fine, sir. We'll start with sequence first. Let's get some idea about sequence. Okay, and then we will discuss about indexed sequence and linear sequence, and we'll talk about one implementation class. We'll see a few examples as well. Okay. So first thing is when you talk about this, well, there are three hierarchies here. If you look at this one, this hierarchy from iterable, it has three childs here: the set, the map, and the sequence. Now let's start with set. Then we'll come back to the sorry. Let's start with the sequence. Then we'll talk about set, and then we'll talk about map. So that's how we proceed. And meanwhile, I will also what we do is we take one implementation class and we see all the methods which were there in the iterable, okay, or which were there in the traversable. We can also cross check all those methods. So now, what is sequence? Now let's have a quick idea here. What is a sequence? So now I'm taking here this iterable has how many kids here? It has three children. What is that? It has a sequence, and then set and a map. So let's start with the sequence. So what is the sequence here? Okay, first I will give a high level idea about these three first, and then we will get into the discussion of what the implementations. Okay, the childs and the implementations. See, when you talk about sequence, it is like this. It is a child of iterable, so I don't need to add this point. Second thing, it is dynamic, and another important thing is it allows duplicates. You can have duplicates in sequence, and one more is it has indexing. What is that? It has indexing. It is an indexed, probably sequences are indexed data structures, so nothing to it. Okay, and also insertion order is preserved. Insertion order is preserved. That is one thing. Okay, so these are all important things. What are important here? The important features of sequence is it allows duplicates, indexing. It is an indexed data structure, and insertion order is preserved. Okay, and it is dynamic, and it is a child of iterable and traversable. Indirectly traversable, directly iterable. Okay. Now what we do is we will quickly check these features whether these are whether we are having we are discussing it in a right way or not. Is this true or not? Whether it is dynamic or whether it is allowing duplicates or not, whether it is indexed or not, whether insertion order is preserved or not. But that what do? We don't need to do anything, sir. Simple. Remove all this. We don't need all this stuff. The easiest way to test it is what is it? Just create an object for sequence. And one more thing, when you look at it, sequence is a trait here. What is this? Sequence is a trait. I'll just show you. It is a child. It is a trait. It is a child trait of iterable. Just giving more clarity so that you can iterable. Okay, one thing. Next. Now what I'm doing is a quick example and a small use case on this to test this properties here. Okay, what are those properties? It's clearly visible to check whether it is dynamic or not, whether it allows duplicates or not, whether insertion order is preserved or not, whether indexing is there or not. Now what I'm going to do is I'm going to create an object for sequence and test these features. Now you have a question in your mind. What is that question? Sir, you told sequence is a trait. Okay, sir, you told it's a trait. Then how could we create an object for it? Correct, right? Is it a valid question? Then what is your answer, sir? Anybody can answer me? No, the sequence is a trait. And we cannot create object for trait, right? Somebody is asking me a question here before going to the discussion of this. What is difference between library or a package? See, in a way, we can treat them as synonyms, Sandeep. Synonym means when I say package or a library, the meaning is almost same. We don't have big difference there. Okay, we can use them interchangeably. I can say package or library, both are same here. You don't need to get worried about it. Oh, sorry, you don't need to get confused about that. Okay. Yes, that's what I am asking here. That's the discussion point here, Srikanth. So, right is something which is abstract, and we cannot create object for that. But what I am doing, see here, something like where some, okay, some sequence. You can see I'm not using uppercase. And one more thing, there is a naming standards followed by all these classes and interfaces. What is that? Every class or trait, the starting letter is always uppercase. Remember, observe that. Okay. So here, my variable doesn't have any uppercase here. You can see now I'm creating an object, some sequence of, you see that 1, 2, 3, 4, 5. Okay. And to our surprise, we don't see any error. And I'm also printing it. I'm iterating it. First, we will do one thing step by step. First, let's understand. So you can see this. I can keep adding how many other elements I want. I can see 8, 9, okay, something like 10. I can keep adding as many as I want. So that is one thing. Means it's dynamic. Okay. What do you mean by dynamic, sir? It's growable and shrinkable. Okay. I don't need to mention any size here. There is no limit. It is unlimited, like Airtel or Jio. This is also unlimited. You can put as many elements as you want. You can put thousands, lakhs, crores also. Okay. But of course, when you have those many crores of values, there might be some performance issue with the RAM. But I'm just giving an idea. So the point is, this is one thing. Second thing, it preserves the insertion order, right? And it is an indexed data set. Suppose you can see now, I am iterating it like for what we do. Shall we iterate through index or shall we directly apply for each, you know, right? We can also, this is like an array, right? We can apply for each. All of you have idea about for each, right? How to iterate, how to use for each, something like for I. Usually for each is exclusively applied on collections. So for I in sequence opening, then you can just print it. But you know, we are just iterating it and getting element by element here. We are not extracting element through index. And suppose you want to know that whether it is indexed or not, we will check that as well. Now let me run it. You can see you have all the values here 1 to 10. Maybe if you want print line by line, I mean element by element. You can apply println here, then just run it. You can see there. Okay, it is dynamic. Okay, fine, because I didn't mention any size and I keep adding data, it will accumulate that data. We don't have an issue. Second thing is, if I want to see the index, whether it is indexed or not, println of sequence of 1, or sequence, you can say sequence of 0, sequence of 1, sequence of 2, like arrays. You have idea about arrays, right? I think you have idea about arrays, right, sir? Like that. I'm just only printing few because usually we don't try to do this. We don't try to extract data with index every time in a real scenario, because we generally do that with iterators. Iterators plays a major role while iterating these collections. We don't try to extract independent elements from each location. Okay, it's very rare that we do. I don't say, but it's in very few cases that might be happening, but not always. Okay. Okay. Feature 1.1, it is dynamic. We are seeing that. Point 2, we are trying to access through index. We are seeing that. And then duplicates. Suppose I might put some duplicates here. You can see 1, and then 2 again, and then 3 here. Now you can see there are duplicates in this collection. So it is allowing that. We have to check it. When we iterate it, then if you see that duplicates, means it is allowing duplicates. Yes, I am seeing them. So it is not filtered. So means what? We don't have a problem here. 1, 2, 3, 4. Again, what is that? Of course, this other output is from here. It is coming from the indexes. Okay, you don't need to get confused. First here, these are from getting from through index. That is one thing. Second thing, through loop. So first 1, 2, 3, 4 is from index, and after that again 1, 2, 3, 4. These are getting from the indexes. This 4, and after that this 10 values. These are coming from the loop. And you can see here the duplicates are intact and the insertion order is still right. It's perfect. No change in the insertion order. Okay, that is one more thing. And it is allowing duplicates. That is one more thing. It is dynamic because we can keep adding more elements now. And also we see it is an indexed data structure. You get this, right, sir? A quick idea. First thing, let's have some quick idea. Later on we'll get into the comparisons. First, once you get some clarity, then we can jump to the comparisons, like why it is, what is difference between that and this. That discussion also happens for us. Now suppose you see, sir, I don't need what this print statements are, these iterators. I can do one thing. I can print this whole object. No, if you want to show one more thing, we had discussed a point yesterday. A collection is used to represent group of objects as a single entity. That's what it is, right? Even we are seeing that here. Now one surprise element for you see here, println of sequence. So there are two things here which might be running in your mind. One thing, sequence is a trait, and our discussion and the proving point is there. We had proved that we cannot create objects for sequence, I mean for traits. The question might be here, how come we can create an object for a trait if if its sequence is a trait? That's one question. We need to get a quick understanding. Second thing, point 2. What is it? So is there any other thing in the background instead of sequence directly? Means that might be also there. First, to answer the first question, so we are not directly creating object for trait. Internally there will be a companion for it. That companion also don't directly use that trait. It will internally uses what again, some implementation class. Suppose to break that ice now, let me just quickly run this and show you some surprise thing to you. Can you see there? When I print it here, you can see that it's what's in printing. Are we seeing sequence or are we seeing list here? What is that we are seeing here, sir? We are seeing list. We are not seeing sequence. Means what? Internally it is using to construct this sequence object. It is not using directly the trait, but internally it is using some list object. You got it right. And one more thing, when you look at that list, you might see certain things here. What is it? You might see that it is holding duplicates, insertion order. Whatever the order you have inserted, the elements are, are stored in the same order inside list as well. No change in that, right? And the index is as well, we have just checked. We can also access elements through index. We can insert elements through index and extract element through index and modify elements through index. Got it right, sir? That's what happens here. That's simple idea about sequence now. And right? So these properties, whatever we have discussed, some 3 or 4 properties, even it is heterogeneous also. If you just see here, sir, one more important point, 10.7 or 1.7 is also fine. Okay. Now, if I run it, you can see there, it's allowing 1.7 means it's heterogeneous. But what's happening here? It's casting everything to the uppercase here. Suppose if I take one string, let me put a string as well. If that is the case, let me put a string, something like Manohar. Okay, let me just run this. What happens now? Still it's list here. So what happened now? Now again you can see the data is as is. Earlier when I put 1.7, all the data had been converted to this. There is a bit of what is that? The behavior is changing. The changing from data to data. If I add integers and decimals, there is one kind of behavior. If I add a string, there is one kind of behavior. Can you see that, sir? Because what happens is in the previous case, if we add decimals, there is a upcasting had been done throughout the sequence. Okay. When I add this string, now you cannot do upcasting. String is a different type and these are different types. These are numeric, these are characters. Then your JVM, now it cannot convert them completely to strings because it's not possible. These are numeric type. So what it will do is it is just converting the data type here. You see, you have to check always the data type. You can see now it made this data type as any. Can you see it here, sir? You have to get an idea about all these very basic things, because tomorrow you might be writing a code. You need to get that understanding of the conversions, like what kind of conversions happening internally, so that there might be exceptions coming. To handle that exceptions, you should have a good hold on all this. Got it right, sir? That's very important. You should have a good hold on this. It's very important. Okay, suppose now if I remove this Manohar, see this. This is string. This is heterogeneous, no doubt about that. One more important thing. Now you check the type here with sequence. Check the type. It is double now. See there. It is double. Means what? What's happening here? How this changing? This behavior is changing here. How your JVM is making decisions. See there. The type of this sequence is decided by, because I don't know what data I want to put in this object. Then you don't declare the data here, data type here before that variable, unless and until you are sure that it has all integers, all doubles, all decimals, all strings. Otherwise, don't try to declare data type directly, because let's JVM decide what the data type should be. But you should be aware of it. You should be aware of the conversions here. Now, as it is the whole numeric, it is considering the highest data type here, double. So it is making the whole data as double itself. This is another important point. Observe these things. The change is happening constantly. That's very important. Okay. So the conclusion is what, sir? Definitely one more important point is it is heterogeneous also. Which is heterogeneous? Sequence is heterogeneous. Okay. So I know I can copy and paste all this and come to you, sir, but just to make sure you get a perfect clarity, I'm doing analysis in front of you and making those points, so that you get a better clarity. That's all. So this is a quick idea about this one, sir. Quick idea. Now you can extract them through indexes, and you can do iterations. There are different ways. Still, there is so much on this. This is just like a tip of iceberg. If you talk about collections, we didn't discuss anything much here. It's just a small thing there, a dot in collections. Whatever we have discussed so far, there is so much in this. Okay, so this is quick idea, sir. So what you do is this is one thing, printing the whole object. Second one, accessing index. We'll add few cases like this so that you get more clarity on this. Accessing index, one more. So just add some printel enough just for analysis only, sir, just to get a clarity, like okay, we can do all these sorts of things on this, just to know that. Okay, some just one or two is enough, sir. You don't need many here, just for analysis. And third one, accessing, iterating through loop. There are so many beautiful things here in collections. We'll talk. Okay, accessing through, iterating through for or loop. Otherwise, anything is fine. You can also apply while loop, sir. We don't have an issue there. So for I in sequence, just simply what is it? Println of I. Okay. So this is a simple, quick program with multiple scenarios discussed here. Okay. So I'm just putting in the chat box. I mean, sorry, to the notepad, so that. So you got ideas, sir? Did you get? Are you clear till this point? Whatever I have discussed here. So what sequence is doing? This is a companion object. Without no doubt, this is a companion. This is not direct right here. It is using a companion. In that companion, again, it is constructing list. If it, right, that apply and unapply methods are. That apply is a constructor where that constructs this sequence object through list. If you ask me, I can, like a creator who try to understand his creation, we can go and look into that. So this will be there in the background. What is that? The behind this sequence object, there will be a companion object. Inside that companion, again, what we have apply method, you remember, right? Inside apply, again, they try to construct this list with the sequence with the list implementation class again. See what's happening there. So that is a beautiful thing in programming. Okay. So would you like to test this program, sir? Please test it, sir. Then we'll talk more. Sir, please, confirm once you are done. This is the idea about what is this? Just the sequence thing. Now, what we do is let us quickly get an idea about set, how this works. I'm just only giving quick idea about the high level rights first. Tomorrow, I'll start again discussing the hierarchy, the whole hierarchy of right here. Now we will jump into this discussion. What is it? We will see again indexed sequence and linear sequence. First, we might take up indexed sequence and see what are all the implementation classes. And then we switch to the linear sequence, and then we will see all the implementation classes and what are the differences. Probably, if you really understand this example, the concept is, even the way we work with list or the vector or whatever it is, the way we create objects is almost same. But there are some changes internally. There will be some different implementation classes implicit. There will be some data structures for every collection internally. That data structure changes from implementation class to implementation class. And also performance wise, certain classes best fit in insertion of data into that collection. Certain classes are best fit in the retrieval of data. Okay, certain classes will be best fit in some other aspects like that. Okay, there will be some kind of differences with these collections. Got it, right? So after observing sequence, now it is very easy. We can quickly get to the discussion of set here. So these are almost the properties are same. What are those? So properties means it is a child of iterable, this iterable interface. Okay, it is dynamic. This is also dynamic. All collections are dynamic, sir. There are no static collections here except arrays. Arrays is a static collection. When you talk about collection hierarchy, the daughters and sons of traversable are iterable. All these guys are dynamic. No, okay, none of these are static there. Second thing, dynamic. Third thing, there are no concept of duplicates. No duplicates. Sir. Set is very strict. You put duplicate, it will fire like so. No duplicates. It will jump that height if you put duplicates. Okay. Indexing. Set don't have indexing. Okay. If you want, we can check with the example. Insertion order. See, insertion order is preserved if you have indexing. And if you don't have indexing, there is no point of preserving insertion order. We cannot predict. Suppose you put some values in that object, okay, in that set object. I cannot tell that when you print that object, the order of those elements will be the same. It might be same or it might be different. So that's what order is not preserved here. Insertion order is not preserved. If it is indexing, simple things are. If it is indexing, insertion is preserved. If it is not indexing, no insertion. Insertion is not preserved. That's very simple. I mean, even set is heterogeneous, no doubt about it. Even set is also heterogeneous. Got it right, sir? So these are important things about set. The major difference between sequence and set, anybody can figure out is sequence allows duplicates, set doesn't allow duplicates. Sequence has indexing, set don't have indexing. These are the core differences. Got it right? So
Sorry, Manohar, can you just repeat the difference between sequence and set?
yes, no issues. See, the basic difference here is sequence allows duplicates. You have seen that with program as well, right, Bharat?
Yes, yes.
But set doesn't allow duplicates. We'll quickly do that. We will check that. Set don't allow duplicates. That is one basic and major difference, if you ask me. So no duplicates per set, but sequence has duplicates. That is one thing. Second thing, Sequence has indexing, whereas set doesn't have indexing. If you want to extract elements from set, you have to apply. What is that we should apply? We have to use iterators. We should depend on iterators. That's all. Like in sequence, we cannot choose index and try to get element by element here from 0, from 1, like that. We don't have that kind of thing with the set or map. This map has some that key and key thing. You got it right, sir? Is it clear, Bharat?
Yes, Manohar.
Thank you. Anyhow,
Thank you.
insertion articles, obviously we know, right? If there is no indexing, then insertion article is not preserved here. But for sequence, insertion article is preserved. Both are heterogeneous, both are dynamic. These are common for both sequence and set. Let's test it now. We don't need to wait to understand it. Instead of sequence, make it as set here. Now you run this. Don't probably you can see here now. I'm talking on that. Don't worry about it. Now when I make this to set here, see sir, I told you just now I have updated on this. What is that? Set doesn't, and one more thing, sorry. Also, we should make this change also. The variable change, name change also should happen. Okay. Then later on we should conclude. Now let us see this now. Here also, what is that called? Okay. Let us try to run this now. It is not showing any error. Probably let me just run this. Okay, we are seeing something different. 1 minute. Oh, when we are trying to print set of 0, set of 1, set of 2. So you are seeing some difference here. One thing, when you try to access through index, so it is allowing index, okay, fine. But what it is giving me is it is giving true or false. I'm not getting the value. That is one thing. Second thing is you are iterating. Iteration is fine, sir. Few things. Generally, set should not use indexing. Okay. Okay. I will talk on that. Okay. Let's first understand, observe the principles or properties which we apply on set here. Okay. First thing, as discussed, first thing is you can see there is no duplicates in this set. One thing. Do you have duplicates? Please verify it. No duplicates. Second one, number 2. See, in the set object, when it is displayed there, you are getting 5 as the starting element. But do I have 5 in the program here? Did I put 5 as the starting element here? No. Insertion order is not preserved because it doesn't use index. Third one. What is the third one? Third one is talking about the index, but sir, you don't have direct indexing in set. That is for sure, no doubt about that. Why? Because now you are trying to get a set of 0, set of 1, set of 2. Okay. Here, instead of you can see there, instead of getting the values, you are getting booleans. Means what? This, of course, false means set of 0. What is trying to get 5.0? Assume that it is giving me false. Then true.
No, no. Actually, I think it will verify whether the 0 value is there or not. If it is not there, it will give false. If 1 is there, it will give true. 2 is
Correct.
there, it will be like that, I think.
Yeah, but even if we can apply that theory here, Madhu, see, even it should return true for all the 3 because there is no 0 here in this set. Correct.
Yes, that's what it has given false, right?
So you are saying, okay, I understand. What you are trying to tell is set of 0, when you pass it, it is treating this as a Boolean value. That's what you are. Okay, I got your point.
It is checking the value in that set.
It
That
is
means it
working.
is taking.
Correct. It is working like a method. That's your point.
Yeah, I can say in that way, member, we can say in member, whether this member is available in that collection or not.
No, 0 is not there,
Member,
right?
member in the sense 0 here.
Correct. But 0 is not at all there in this set. Correct.
Correct. So that is what it is giving false, I think so.
So okay, if 0 is not there, then okay, it is checking, means this is acting like more or less like a method, not like it is not extracting that index, right?
Yep, correct. But in
It is
for loop, it is taking as,
correct. You have, that's what the point we had discussed. Generally, set doesn't have index in not only here, not anywhere. If you look at the data structures, set don't uses index. Usually, this list or vector, this classes of sequence will use indexes. Probably we will also just check it in for clarity purpose. Now, these are all important. See, when you come to such things, the set uses indexing Scala. And you can see here, you can't get collection element by index. Can you see that? So there is one more thing. And probably because I'm sure on this, because set doesn't apply indexing. So they apply these methods. And as discussed, this constructor, whatever you are trying to check here, this acts as a constructor otherwise. Okay. When you say set of 0, okay, let me check for 2. That's fine. Let me give it as 100. Okay. So this is not there inside that. Let me give 10. Now you got 3. Correct. Madhu, that's perfect. This method, what it is doing is it's acting as a method. It's not trying to get the index here. It's not working like index. What it is doing is when we pass something to this set method, this is acting as a method actually. When we pass to this, what it is doing is if this element is present in that, it is returning true, otherwise it is returning false. But it's not like extracting the index. And the point is index is not applied, and hence we can clearly confirm this. Index is not applied on set. So what we can do, if you want to extract elements, the choice for us is applying iterator. What is it? Through iterator, we can apply. We can access elements. Maybe you can ask me. Otherwise, there is another way. What is it? If you want, if you are concerned about the index, if you want to access them through index, then we can convert this set to list. We can convert this set to list. Then we can apply indexing on that list. That is also possible. Got my point? But by default, set don't uses indexing internally. It uses something called hash code. Which we have discussed sometime earlier before. It uses something called hash code. You got it right. We'll talk more on this in tomorrow's session. But you got it right. What is this method doing here? This is just checking what are the element you are passing to this, whether this element exists in this set or not. It is not the index. It is not supporting the index here. It is only just looking for this value. Whatever you are passing to that method is present in this set or in this object. That's all. Got it? Is that clear now? Thank you, Madhu, for adding some more points to this. We will talk
Thanks,
on
Madhu.
we will see it, Sandeep. We will discuss all that. Yes, contains kind of thing will be there here also, not exactly contains. Okay, we will discuss. We will just look at the all the methods. From tomorrow, what we do, we will start doing method by method. Then, if contains is there, then we can also apply to contains. Okay, we'll see that the all the list of methods there. Okay, right. Is this fine for all of you know? So finally, these are valid points, no doubt. It doesn't uses still indexing is not applicable for set. Okay, is that clear now? It doesn't uses indexing. Sir. This is sure. We can clearly add this point here. No indexing, no duplicates. Inserts not are not present. We have seen that in the output as well. Okay, and also it is heterogeneous, like a sequence. This can be heterogeneous. We don't have an issue with that. And right, as we are adding double, it is converting the whole set to double. Maybe if we add one more string to that, it will convert to any. Then you can see data as is, something like this. If I add like this time you can see that. Now we are seeing that data as is because int is kept as int only, double is kept as double, string is kept as string. Got it right, sir? Hope this is clear now. There are so many things to discuss. This is not at this is we have just only started. We need to discuss so many things. Okay, we'll see tomorrow, sir. All of you are good now? Are you good, sir?
Manohar, one quick question.
Yes.
We have given this sequence or set, right? At the initializing part. After that, we are printing the set. Can we again assign some new value there afterwards?
Yes. See, it depends on type of set we are using. Are you using immutable set? Immutable set. If it is immutable, probably we cannot modify it. If it is mutable, we can modify it. That we
No,
will
we are
discuss.
using. If we are using the same set.
Yeah, this by default mutable. Default probably it is using mutable, so we can modify it. Bharat. We'll see those methods also. How to modify, how
Okay.
to update.
Okay.
I didn't jump into the methods now. Once we finish all those methods, you get an idea. Like how to update, how to delete, how to add, okay, and then how to check whether an element exists in that or not, how to get the size, okay, and then like this, there are so many methods. Got
Okay,
it?
okay, Manohar. Got it. Got it.
Tomorrow probably once I will just quickly introduce map and jump start to this implementation class. We take one implementation class and we test all those methods which are there in the traversable. Then automatically you get an idea about all the methods first, so that the same thing we can apply on remaining collections like set or map also. Okay, right. We'll meet tomorrow. Thank you. We'll stop this here.